Well, she has.
Alright, so let's begin. Does anyone know what entropy means? It's like chaos, right? So in terms of chemistry, we're talking about entropy more than chaos, but more randomness and disorder. Okay, because we're going to look at it in terms of what are the molecules actually doing themselves. So we think about entropy as randomness or disorder.
So we think.
Right, and you've heard like the universe tends toward disorder. If you clean your room, it's going to start getting messy again, right? It's kind of the same idea, but talking about chemicals on a molecular level, atoms and molecules and how they're reacting and what they're doing.
If you have like electron movements.
Not electrons, atoms and molecules. We're not going quite as far as electrons. We're still talking within a chemical reaction, okay? Now, when we talk about entropy, we want to look at the energy and the movement of the molecules. And when molecules move, they can basically move three ways. Motion, that's a better word. Movement, moving around motion. Okay, so when molecules are moving around, they can either move with translational motion, rotational, or vibrational. All right. So what does translational motion look like? Yeah, so like if I'm a molecule and I move over here, right, that's translational motion. That's what gases have because they can move all around. Liquids have some translational motion, but it's going to be a lot less than gases, right? Will solids have any translational motion? No. Okay. Now, rotational motion, what does that mean?
It's like turning.
Yeah, like rotating about an axis. Okay, so what has rotational motion?
Liquids.
Liquids do,
Yeah,
gases do. Okay, solids will not. Vibrational motion.
It's solids.
Well, it's all of them, but also
But
solids.
solids.
Because vibrational is basically the bonds are kind of stretching and contracting, right? So they're vibrating within themselves. So solids will have vibrational motion. Gases have all of them, liquids have all of them, but in a smaller extent.
So basically fluids for all of them, and then vibrational is all the liquid, solids, and gases.
Yes, exactly. All right. So the more motion there is, the more disorder, the more randomness there is an increase in entropy, okay? Now, entropy, I didn't put this at the top, is capital S. Delta S, change in entropy, obviously, just like delta H is change in enthalpy. Okay, now we call the amount of motion that something has the number of degrees of freedom.
This is solids.
That's not what it's
American. But we're in America, isn't everything?
So, for example, gases have more degrees of freedom than solids do because they have more types of motion available to them.
Basically, they know math.
Yeah, and it refers to molecules and how they're moving around each other. So, yeah,
Okay,
we're looking at
entropy is the number of degrees.
yeah. So the more degrees of freedom a molecule has, the more entropy it has. Yes.
So is the number degrees of freedom, is that going to be a unit?
No, it's
Or
basically how many ways can it move around.
So would it be like 1 to 3, or is there like a different
Well, there's
scale?
more to it than that, but yes, like gases have more degrees of freedom than liquids do, than solids do, right?
And how would that correlate with entropy?
The more degrees of freedom, the more entropy something has. The more
But they aren't
randomness, the
the
more
same.
disorder. Yeah, but we're not looking at values yet. We're just talking about what is entropy and what causes more or less entropy. Okay. So what you need to be able to do is to predict the sign of delta S based on three things: temperature, volume, and number of moving particles. Okay, for example, when you increase the temperature of something, what do the molecules do?
They move faster.
They move faster, which means there's going to be more disorder, right? Faster they're moving, the more translational motion they have, right? So, higher temperature, more disorder. Now, that means delta S will be positive or
Higher
negative.
positive.
Well,
Yeah.
if the temperature goes up, it's not.
Right. As the temperature increases, delta S would be more positive, right? Okay, what about volume? What if you take a gas and then you put it in a bigger container?
It
It'll
will
slow
be
down.
free, it'll be
Negative.
free to move around more, but there'll be less collision.
More collisions.
Okay, but we're not talking collisions. Yeah, pressure would change, but we're talking about entropy, right?
They
So
have
if they
more.
had more room to move,
It'd be great.
Oh.
there's greater entropy, more randomness, more disorder, because they're in a bigger space, they can move around more
So
freely.
Temperature goes up, delta S goes up?
Yes.
But
Same
even though
with
they
volume.
can go faster when they have a bigger space, it's still.
No, that depends on temperature. So the pressure will go down if volume goes up, if they're moving at the same speed and they have the same kinetic energy, because it's gonna take longer for them to collide with the container. So we're just changing one thing at a time, right? Okay, and then if you increase the number of moving particles, what would happen?
More
Increase
collisions.
More entropy.
More entropy,
Remember, think
because
about
there's
it
more
as
randomness.
disorder. There's more stuff
Like a
moving
city
around.
has more like incidents and stuff. because
Exactly,
more people.
yes.
Okay.
So when would you see an
Right.
instance of increasing the number of moving particles?
When you add more
Can I
gas.
add
Yeah.
mass or more?
Say it again, Sydney?
When you change it from a solid to a liquid?
Right, so if you convert from a solid to a liquid, you have more moving around particles. When you convert from a liquid to a gas, the particles are gonna move around more, so that would be an example. If you had a chemical reaction where a solid is decomposing into a gas, right, you're gonna have more moving particles. If you dissolve something in a solution, what happens?
You're introducing more particles.
Yeah, because you have a solid, it's breaking apart into ions, and the ions are free to move around with the water molecules. That would cause a greater disorder, right? So there's lots of ways that you can have more moving particles, and we're going to look at some examples of those. Okay,